Okay, here we define the expected value or the expectation of a random variable. Here we do the experiment where we flip 2 coins and count the number of heads. This is a random variable. Let's compute its expectation. There's an alternative method to compute expectation, which is much more efficient. Okay, now let's consider the case where we flip 4 coins, let x be the number of heads, and let's compute the expected value of x. All right, here's a very useful theorem. If y is a function of x, then we can compute the expectation of y through a formula that is similar to the expectation of x. We just have to replace k with f of k in the summation. Let's again revisit the question of flipping 4 coins, let x be the number of heads, and now let y be the number of heads squared. What's the expected value of y? Here's an important fact about expectation. It is linear. We will state and prove the theorem that tells us this. The expected value of alpha x plus beta y is alpha times the expected value of x plus beta times the expected value of y. Let's consider the example where we roll 10 dice, add up the numbers, and ask what's the expected value of that sum. Now we define conditional expectation. Given any random variable and any event, assume that the event has probability that's positive, we can now define the conditional expectation of x given A by the following formula. Now we have a very important formula. It's called the law of total expectation, and it tells us that we can compute the total expectation of a random variable by computing the conditional expectation of the random variable based on a series of events, as long as we weight those conditional expectations properly. Finally, let's go back to this game we talked about before, where we flip a coin. If it's head, we roll 1 die. If it's tails, we roll 2 dice and add them. What's the expected value of this game?